split it into its original left and right sides. So I'll use the word that seems So it's not a question after you've done some work to it. It's the original question. You lop it to two separate chunks, the left side and the right side, and they'll never meet again. Okay, and this is expected of you. If you skip right into solving it without doing this line, you're going to get penalized. Okay, so make sure you do that. Of course, there's the proof along the line. So I'm going to say step 2, do the proof. Step 3, you make your conclusions. I expect these. If you don't put them there, I'm going to penalize you. You finish off with telling me about how your left side and right side look. And then you state the original question. I will demonstrate these time and time again, so these will hopefully make sense. So you take the original 2 parts, you're going to do all the work, and you're going to make a conclusion. Was your left side equal to the right side or not? Therefore, was the question true or not?
What is a proof?
A proof is determining, is it really true all the time? Is 2 equal to 1 times 2 all the time?
Yes.
Okay. Keep in mind that we have thetas involved. Okay, so we're going to be proving stuff like sine squared plus 1 minus sine squared equals 1. Is it true, and is it true all the time? By manipulating these using our identities, we're going to be able to say that for sure that statement was true. Okay? All right, so let's start off with a small example. Tan cosines. Step 1, split the question into its left and right side. And I don't write the full word, I just go LS and RS. My goal is to work one or both sides. I don't have to work them both. If I want to work one, that's good. I can work both. But I want to end up where they have the exact same thing written on them. So for example, I want this side to be manipulated so it says sine, or I want to manipulate this side so it eventually says tan plus tan and cos. Or I want to work both of them so they both say something else, but they got to say the same thing. Okay? If I can get them both to have the same value, then I know this was true in the first place. So, we consider my list of suggestions. If we try this first option on that one, which one would I like to get rid of?
Tan.
Tan. Can you look on your sheet and tell me another way of writing tan?
Sine over cos.
1 over cotangent? Sine over cos?
Yeah.
Yes? And I go back and I regroup. What can I do? Is there something I can clean up?
You can get rid of the coses.
That's right, because this is a numerator and this is a denominator, and they're times. So you're right, they cancel each other out. What's it worth now?
Sine.
Sine.
Theta.
So I've managed to get the two sides to be the same. In this case, I only worked one side. I write my two conclusions. The left side equals the right side. Therefore, this is true.
So if they didn't equal, how would you write
Which
therefore?
switches to a not sign
Okay.
and a not sign. It's possible that the question is true, but you're just not having any luck. So at some point in time, you just concede and go, well, maybe it wasn't true in the first place. Okay. How can you find out if this should result in a true response or a negative response? Put a number in. Because according to an identity, if I pick a number of my choice and I put it in here, it should result in the same value. So you can check the original identity to see if you should be getting true or false. Right? Try it. Pick some weird number like 61.2. Pick something like 45. Works. Right. So here's another one. Tan plus 1 over tan
What is to me?
equals 1 over sine cos.
Are the x's the same as theta?
If you don't like the x's, write the whole question using the symbol you prefer, but don't change it in the middle, like, you have to do the whole question. Okay, you guys help me out. What do I have to do first?
Left side, right side.
I say it all the time. If you don't do this as part of your homework, the habit to do it will not surface when you do the test. You'll just skip over it. So don't skip it because it's annoying to do. Now, I've given you some very specific scenarios, but often when I'm verbalizing what I'm seeing in a question, I'm saying other things. So you can add things I comment about. Like right now, I'm looking at this and I'm going, I see tans, sines, and coses. I'm thinking I'd like them to all be this again. That's one option. I can switch everything to sines and coses. The other thing I see is this is a fraction. So I might consider making a common denominator. Okay? So those are the things that jumped out at me right away. I think I'll go with this first. Somebody tell me what it would be if I replaced those tans.
Sine x over cos x equals 1 over sin x over cos.
What is 1 over tan?
Cotangent.
So therefore, what can I change? Read? I'll slow that down to show the step in between.
Yeah.
Good idea.
It avoids the part of having a fraction down there. If you realize this, it saves you doing a fraction division. I'm still seeing this. So what do you guys think the common denominator would be?
Sine times cosine.
I need both of them, right? So sine cos. So what is the first one going to need introduced to it? No those of you who are not really strong at your fraction skills, I highly recommend writing this stuff down. What does this one mean? So when I introduce the missing pieces,
Just bracketed and squared.
you mean like go sine x squared? I could do that, but sine x squared is the same as saying, okay, bottom. I think I'm gonna write them in that order, since that one is sine first, so sine then cos.